Here are a couple of examples of how to solve a system of three equations, three variables, using a process called row echelon form. So I went ahead and took the given system, which you see here in red, and I transformed it into an augmented matrix, which we have here in blue. And so let's get started. So the goal, again, is to have a matrix that has a diagonal row of ones, starting at this top left and then just working our way down. And then below that diagonal row of ones, we have a triangle. It's like a right triangle of zeros. And then for row echelon form, these will still be numbers up above this upper right hand or right triangle. That'll be numbers. There's a process called reduced row echelon form where both of these triangles will be zeros with a diagonal row of ones. And then these numbers would represent the final solutions. We're kind of doing an abbreviated process of that called row echelon form without the reduced. All right, so my goal here, the 1 is already established. I need a 1 here in this spot, so that's already done. So your way of thinking through this, your methodology should be make this become 1, and then go ahead and take care of the rest of this column. All right, so my next move will be to force this 2 in this second row, first column, second row. That needs to become a 0. And then after I get that done, I'll work on this becoming a 0. All right, so I'm just going to step through and describe my row operations each time. So my first row operation will be multiplying -2 times row 1, and then I'm going to add that to row 2, and then that is going to become, the arrow just means this is going to replace the existing row 2. All right, so each time we define a row operation, then we'll put the result. Okay, so my new row 2 is going to become -2 plus 2, which is 0. -4 plus -4 is -8. +2, I'm multiplying -2 times -1, that's +2 plus 1, that's 3. And then +6 plus -7 is -1. And then I haven't done anything with this step to row 3. Okay, my next move then is to take care of this -2. So it's going to be similar. I'm still going to use row 1, but this time I'm going to multiply +2 times row 1, add that to row 3, and then that's going to become the new row 3. All right, so row 1 obviously is pretty much done. Row 2 from the previous step. And now row 3 is going to be 2 times 1 plus -2. That's my 0 that I need. 2 times 2 is 4, plus 2 is 6. -2 plus -3 is -5. And -6 plus 4 is -2. All right, so I'm pretty much done with this first column. It's the way I want it. Now I'm going to target this -8. That needs to become a +1. So row operation number 3 will be -1/8 times row 2 will be my new row 2. Right, so -1/8 times 0, -1/8 times -8, -1/8 times 3, and -1/8 times -1. And so far with this row operation, row 3 did not change. Okay, now I'm going to target this 6. I need to make it become 0. So row operation number 4 will be -6 times row 2 added to row 3 becomes the new row 3. All right, let's see what that results in. 1, 2, -1. Obviously you want to make sure, be careful to rewrite your numbers correctly. just one little mistake will throw off your whole answer. All right, let's see what my new row 3 is going to be. So I did -6 times row 2 plus row 3. Well, that still keeps 0 here. -6 plus 6 makes 0. And now we have to deal with fractions. So -6 times -3/8, that is 18/8, which we could reduce into 9/4. All right, so we're going to be adding 9/4, so we might as well go ahead and change -5 into fourths. 9/4 plus -20/4 is -11/4. Okay, so you can see where that came from. And finally, we're going to do -6 times 1/8. That's -6/8, which of course is -3/4. And we're adding that to -2, which is -8/4. And we get -11/4. All right. And the only step left is to turn this -11/4 into +1. So that would be my 5th row operation. I'm going to say 4/11 times row 3 will become row 3. Okay, so 1, 2, -1, -3, 0, 1, -3/8, +1/8. 0, 0, and when we multiply, that should be negative, sorry. When we multiply by -4/11 times the reciprocal, we get +1, and we're going to get +1 here as well. When we multiply -4/11 times -11/4, that's also +1. All right, so we have achieved what is called row echelon form. And next year in pre-cal, you'll go ahead and keep going and you'll do reduced row echelon form. But we know what the solution is for z. Z in this case, this is like saying 1z is equal to 1. Right, so z is 1. And now you just do backward substitution. This middle row really represents y. If you were to write it in equation form, it would say y minus 3/8 z is equal to 1/8. Well, we know that z is 1, so it's like y minus 3/8 is equal to 1/8. And so if you add 3/8 to both sides, you get 4/8, which is 1/2. All right, and then this final top equation, if we were to look at it back in its original equation form, it would say x plus 2y minus z is -3. And so again, we're just doing backward substitution, trying to solve for x. 2 times 1/2 is 1, minus z, which is also 1, and that equals -3. So obviously 1 plus -1 is 0, so my answer for x is -3. So you typically will, just like you would have if you use substitution or elimination or Cramer's rule, which we're not doing yet with 3 variables, the solution to this 3-variable, 3-equation system should be an ordered triple. So 3, 1/2, and 1 is my final answer. So -3, 1/2, and 1. All right, I thought I'd just go ahead and do one more, just so you can see this again. The process really never changes. So let's just take a look. the routine is the goal is always the same, and the way you go about the goal is pretty much the same. Now, obviously, we're using different numbers each time, but the overall process pretty much is very repetitive. So I took the red system and I translated it into an augmented matrix. And just double checking, make sure I wrote the coefficients and the constants correctly. Looks like I did. So let's get started. Once again, we get started off well because we already have the 1 that we need. So you're just working this way. You're taking care of the first column. So that means since we already have our 1 in place, we're going to work on these two becoming zeros in that order. The 2 becoming a 0 first, -3 becoming a 0 next. This problem is really nice because we already have our 1 in place here. So then I just have to work on making this become 0. And then finally, this will need to become 1, and then we'll be done. So probably get through this one a little bit faster. So my first move, row operation number 1, will be -2 times row 1 added to row 2 is going to become row 2. All right, so row 2 will be -2 plus 2, which is 0. 4 plus 1 is 5. -6 plus 1 is -5. And -14 plus 4 is -10. And then, as of right now, row 3 isn't changing. But that will change with my next step because I've got to make this -3 become 0. And so I'm going to do +3 times row 1 added to row 3, replacing row 3. All right, so 3 plus -3 is 0. -6 plus 2 is -4. 9 plus -2 is 7. -20 or +21, keep wanting to look at that. 3 times 7 is 21, plus -10 is 11. All right, very good. Well, I thought we were going to be okay, but obviously in doing that row operation, we have changed that 1 into a 5, so we can take care of that. So this needs to become a +1. Easy enough. I'm going to multiply 1/5 times row 2, and that will become my new row 2. Zero, 1, -1, -2. Row 3 for now isn't changing. All right, now the -4 with my next move has to become 0. So I'm going to do +4 times row 2 added to row 3 becomes row 3. Zero, 1, -1, -2, and now 4 times row 2. So obviously that's going to remain 0. Don't want to mess that up. 4 times 1 plus -4, that's 0. And then -4 plus 7 is 3. -8 plus 11, also 3. And then my fifth move is to change this 3 into a 1, so 1/3 times row 3 replaces row 3. Zero, 1, -1, -2, and now the new row 3 will become 0, 0, 1, 1. Okay, so z is 1. That's what this bottom row tells me. So doing backward substitution, this says y minus 1 is -2. So this is the coefficient for y. So -1, or I'm sorry, for z. This is the coefficient for z. -1 times 1 is -1. So you're just solving that little equation. So y is going to be -1. And then this represents x minus 2y plus 3z is 7. So negative 2 times negative 1 is positive 2, plus 3 times 1, z is 1, and that equals 7. So you're subtracting 5 from both sides. 7 minus 5 is 2. So my final answer as an ordered triple, x is 2, y is negative 1, and z is positive 1. So maybe I'm hoping with those two examples, and of course, doing your own practicing, I don't think the process is necessarily hard. What usually catches people is just little mistakes. You do have to be careful as you work your way from one row operation step to another. So just be careful about those little things, pay attention to detail. And if this doesn't help, if you have more questions, obviously send me an email or come by and see me during academic support. I'll be glad to help you.